I'm Adam Marcus. I am an associate professor of architecture here at Tulane. Studied undergraduate architectural history and theory at Brown University and did my master's of architecture at Columbia University. I direct my own independent architecture and design practice called Variable Projects here in New Orleans. And I'm also a partner in Futures North, which is a public art collaborative that explores the aesthetics of data. So the focus of my research is developing critical approaches to computation, fabrication, and robotics in architecture. This is pursued largely through public art commissions, where we develop experimental material assemblages that seek to open up new forms of public engagement. In my academic research, my work often focuses on developing new approaches to materials and how technologies like robotic fabrication and design computation can enable us to design new types of materials, new geometries, new forms that can relate directly to ecological performance. So for example, how might an architectural facade be designed and optimized to create habitats for other species like plants and animals? A number of years I've been collaborating with a team in the San Francisco Bay Area to develop optimized underwater substrates for upside down floating reef systems, to think about how a surface can be designed and optimized to create diverse habitats for marine invertebrates. So this is one way of thinking about how architectural design and fabrication can open up new ways for us to think about climate adaptation in flood zones and areas that are prone to storm events. More recently at Tulane, I've begun a research initiative looking at architectural ceramic facades as a site for expanding biodiversity in urban environments, but also thinking about how ceramic geometries and panels can be designed and optimized to respond to things like stormwater retention or daylighting and solar shading in extreme climates. I think this is a really exciting moment for Tulane School of Architecture. Tulane School of Architecture is a real leader in thinking broadly about how architecture responds to environmental change and climate adaptation. We have expertise here among the faculty ranging from the region and the city all the way down to the work that I do at the kind of scale of the material. I can't think of a better context than New Orleans and the Gulf Coast to think about the effects of climate change on the built environment. And I'm excited to develop new collaborations with faculty and students here at Tulane to think about how we might not only envision strategies of adaptation, but also prototype and test and deploy and implement ideas for new architectures that can respond to environmental change.